Hi 8th grade, welcome back. We're at lesson 2, session 3. Last lesson we learned about reflections, and now this time it's rotations. Now rotations aren't my favorite. I think reflections and translations are definitely my favorite. Rotations are okay, they're whatever. But, so we'll get through it together, I guess. Okay, Jamal draws triangle PQR on the coordinate plane as shown. He rotates PQR 90 degrees. Now remember, 90 degrees would be like, see how this is a 90-degree angle right here in that coordinate plane? It'd be like if I had this dot on -4, 0, or 0, -4, it would rotate exactly to here, because that's 90 degrees of a rotation. And then another 90 degrees would be 180, and so on for 360, okay? So remember that, 90 degrees literally means it's going to flip from this area all the way up to this area. But we also have to be careful, because if it says counterclockwise or clockwise, that'll change everything too. If it's going clockwise, it'll go that way. If it's going counterclockwise, it'll go that way, okay? Okay, so let's go ahead and figure this out. Jamal drew triangle PQR in the coordinate plane. He rotates it 90 degrees counterclockwise. Okay, so it is going to go this way, around the origin. Now this is super important, around the origin. Remember, the origin is this little guy right here. He's the center. What that means is that it's not like my stool. Remember how I took my stool and I was rotating it just on one leg, like a pivot in basketball? That would be if I was pivoting on one of these little points. I'm not pivoting on a point. Instead, I'm pivoting in the origin. Think of it as like a clock, okay? The origin is the center of the clock, but this is like the clock hand, okay? It's going to pivot around the origin. The origin is the pivot, all right? I'll show you what I mean. Let me get rid of my little dots and drawings. Okay. What are the coordinates of new PQR if it rotates 90 degrees counterclockwise? So let's think about this. 90 degrees counterclockwise. We know 90 degrees would be in this coordinate plane, correct? We also know it's not just a flip. I can't just now count spaces. It's going to be a little bit different than that, okay? So let's talk about all the different ways we could possibly do this. You might want to use like transparency paper or tracing paper, and you could trace PQR and then rotate it and just see where it would land. And you could do that by showing me exactly where 90 degrees is, by tracing that as well. I wish I had the option to be able to do that for you guys. Let me see if I can just try it out. Okay, let's see if I can move this shape. Whoops. If I were to trace this, I'd have to resize it, because I'm not just sliding it, remember. I'm going to try to do it without changing the size, okay? See, this is kind of difficult for me to do. Okay, let's try. Oh, there it goes already. So it would rotate. Yeah, see, this isn't going to work with me trying to do it on here. I could easily do this on Google Slides, though. Hold on, let me try something. Okay, it'd be really cool if I could show you that. Remind me to show you in class. I want to try to show you in class how I can rotate in Google Slides to show you. But let's just say I am just tracing it. I would rotate it with my paper. I can kind of eyeball it, I guess. I would say P would land about, if it rotated 90 degrees, it'd probably land right there. P is 1, 2 away from Q, so Q would be kind of like right there. And then R was here. R would be like right here, sort of. Okay, so this is me just eyeballing it. We'll find out the like correct math way to do this. But this would be P, this would be Q, this would be R, okay? So everything just kind of rotated 90 degrees. So P prime would equal 1, 1. Q prime, oops, squared. Q prime would equal 2, 3. And R prime would equal 4, 2. Okay. You know, you could think of it too, and by actually like flip your book 90 degrees, and then you would see what's in the new coordinate. We'll talk about that in class later, okay? Let's do the picture it. So you can draw the image in the coordinate plane. You can think of the rotation as moving it into a circle like a clock. 90 degrees is a fourth of 360, so it would just move a full coordinate plane, okay? Think of each vertex as being on a circle. Then move the vertex counterclockwise 1/4 turn of that circle. PQR is the image of PQR rotated 90 degrees counterclockwise around the origin. So basically, they're just showing you here, picture everything is kind of like on its own little circular path, okay? You can identify the coordinates of the vertices of the image with the coordinate plane. Here's a table. Let's go ahead and fill out the table. So we see that P is now 1, 1. Q prime, what did we change Q prime to? Q prime is over 2 up 4, no 3. So it would be 2, 3. And then R prime is over 4 up 2. Okay, let's see if we notice any patterns real quick. I noticed that the numbers switched places. Do you see that? Ignore the positives and the negatives for a second. Do you see how the 2 and the 3 on Q switched and the 2 and the 4 on R switched places? You can't really tell with the P because it's just a 1 and a 1. But I also noticed that the signs changed because this coordinate is the positive coordinate. This is the negative positive, the negative negative, and the positive negative coordinate. So that's kind of interesting. Basically, it's the same coordinates, but they switch places, and then you have to give them the sign of the coordinate that they're in. So the coordinate plane positive, that's why they're all positive. Okay, it started out in the plane positive, negative, and that's why these are all positive, negative. There's a cool trick. That makes it a whole lot easier. Okay, so we pretty much did almost all of this. Use the graph and picture it to complete the table, which we did. The table shows how the coordinates change when you rotate 90 degrees counterclockwise. So now they're just showing you how the two numbers flipped. Flip, 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 flip. Okay? And then do you see how the signs change depending on where you flipped them? It says compare the coordinates of the image point to the original point. So if you look, the original could have been 2, 1. Do you see how this is a positive, this is a negative, this is a negative, negative, and this is a positive, negative? So it looks like if that shape rotated 90 degrees counterclockwise, it almost looks like they all switched. You can tell the 4s switched, the 2s switched, but do you see how their negatives and positives went opposite? But not always. Do you see how these guys stayed the same? These guys stayed the same. These stayed the same. These stayed the same. Oh, this is so interesting. I see so many patterns. Oh my gosh, you guys. This is so exciting. Okay, I'm going to erase all my little chicken scratch, and I'm going to get my highlighter. Oh, wow, look at all these cool new patterns. Okay, so not only did they switch places, right? Switch places, switch places, switch places, switch places, switch places, switch places. Not only did they do that, but how strange. Okay, the blue, let me see if can I make a new blue color, or is this all the colors I get? How sad is that? Yeah, okay, blue. The blue, oh, now it looks purple, ew. Okay, the blue coordinates stayed the same. What I mean is like they're negative, they stayed the same. They're positive, they stayed the same. But the pink coordinates, or the red coordinates, whatever, they change to an opposite. So like they're still the same number and they still switch places, but what was once positive 1 is now negative 1, and what was once positive 3 is now negative 3. How fascinating. Okay, so that's going counterclockwise. And now let's look at this one. This one is going clockwise. Let's see if that pattern changes. So it looks like they still switch places, just like before, so that's the same. They switch places, that's great. But now look at this. This guy switched to his opposite. This guy switched. Oh, so the X's switched to their opposites. But the Y's, they stay the same. If they're negative, they're negative. They're positive, they're positive. You guys, can we create our own rule right now? Oh my gosh, this is so exciting. Here is this rule we just now learned. If you rotate counter, I should be writing this up here. Let me go ahead and just, come here. I should be putting it up here because this is where we talk about counterclockwise, correct? If you rotate counterclockwise, the numbers, the coordinate numbers switch places. They still switch places, right? I'm going to say the numbers switch places. And I'm going to go with the original, okay? The original Y's switch to their opposite sign. The original, I'm running out of room, Y coordinates, I'm going to say C-O-O-R-D period. I'm not going to spell coordinate out. The original Y coordinates switch to their opposite. Oh my gosh, that's so awesome. Okay, so if you're going counterclockwise, the numbers switch their places and the original Y coordinates switch to their opposite, okay? Now I'm gonna literally just circle this whole thing. I know you can't do this, you're so not lucky. I'm going to copy it and I'm going to paste it down here if I can. I wonder how I can paste it now. Oops, I grabbed too much stuff. Copy. Oh, well, maybe I'm not so lucky. I was going to try to copy and paste it. That's silly. Oh, that's fun. An alarm is going off nearby, and I can't find it. Well, shoot. I thought I was going to do something real sneaky over here and copy and paste this so I don't have to rewrite it. Oh, well, that's okay. Such is life. So, down here, I'm going to write it in a different color. Green. If you rotate clockwise, the numbers switch places and the original X coordinates switch to their opposites. That is such a fun little pattern we noticed. I guess the hardest part of this pattern is remembering. Counterclockwise means Y's switch to their opposites. Clockwise means the X's switch to their opposites, okay? Okay. So number 4 is literally just asking, what do you notice about if we have a point X, Y, they're both positive, and let's say it rotates 90 degrees counterclockwise, CC, what will the new points be? If we have X, Y, and it goes counterclockwise, remember, first of all, they switch places, right? So this would be Y, X, because the numbers switch places. And then the y coordinate switches to the opposite. So the y was positive, so now it's negative. What if it rotated clockwise? Clockwise, C for clockwise. Remember they switched, so it's going to be x comma y. And then the x switches to its negative. Oh, how fun! Okay, think about the models and strategies we've discussed today. Describe one of the ways that helped you better understand how to solve the problem. So, okay, yeah, you could take some tracing paper and trace around the shape and then rotate your paper, or you could rotate your book. Okay, those are like the easy ways of going about it, but listen, the mathematical way is these cool new tricks we just learned, okay? I highly suggest you guys try to memorize these little tricks because that'll be super helpful to rotate around. Just remember, if you rotate counterclockwise, the numbers always switch places, so like the x's and the y's flip, and then the y coordinate switches to its opposite. And then if you rotate clockwise, the numbers switch places, and then the x coordinate switches to their opposite. All right. Sorry, this video is getting a little long. I was getting really excited there. Let's practice this using this method, okay? Carter rotates JKLM 90 degrees clockwise. Okay, clockwise means it's going that way. Think of a clock. Around the origin. Okay, so the origin is the point of rotation, which is great. And it forms WXYZ. Draw WXYZ. What are the coordinates of WXYZ? Okay, so here, I'm going to do something that might sound crazy. First, I'm going to find the coordinates of JKLM. Okay, I'm going to write them up here so they're out of the way. J, K, L, oop, running out of space, M. So J's coordinates are -1, 2, 3, 4, and then up 1. K is -4 up 1, 2, 3, 4. I'm going to zoom in a little bit. And then L is -2 up 6. M is -1 and up 5. Okay, now guys, hear me out. We are going clockwise. If we're going clockwise, that means we're going to be using these rules right here. The rule says the numbers switch places, and then the x coordinate switches to its opposite. So let's try it. I'm going to do the new ones in red, okay? So the numbers switch places, so this would be 1, 4, and the x switches to its opposite. So what's the opposite of -4? +4. You don't have to write a positive there though, you guys. Okay, so do it again. They switch places, so now this is 4, and this is -4. But the x switches to its opposite, and this was the x, so now this is the new x, and it's going to go positive, okay? Let me get rid of my chicken scratch here for a second. And this would be +4. Okay? So first the numbers switch places, so this would be 6, -2, but the x changes to its opposite, which would make this +2. 5, -1, but the x switches to its opposite, which would make this +1. Okay. That would make this W, X, Y, and Z. See how they, correspond to one another? Okay, now let's go put these in and see if it's a nice little rotation. So we want to go over 1, up 4. And we want to go over 4, up 4. Over 6, up 2. Over 5, up 1. Oh, you guys, this is looking good. Holy smokes, everybody. I think we did it. Now I just have to label it. W, X, Y, and Z. Wow. Holy smokes, you guys. That is the coolest trick ever. As long as you can remember it, and I know it's kind of hard to remember, we'll have to practice, but as long as you can remember that you switch the two numbers, and then if it's clockwise, the X changes to its opposite. If it goes counterclockwise, then the y changes. That is so easy. Yay. Okay, how fun. Let's go number 7. Oh my gosh, what is that name? Shanika. That I will not be naming my baby Shanika. I'm sorry. Shanika draws figure ABC in the coordinate plane. She rotates ABC 180 degrees clockwise. Remember, 180 is like 1 coordinate plane, 2 coordinate planes. So it's gonna be in here somewhere, okay? All right, and it forms prime ABCD. Draw the figure prime ABCD. What do you notice when you compare the corresponding x's to the corresponding y's? Okay. Now, hold on. I know this rule works really well if I'm going 90 degrees, but does it work if I'm going 180 degrees? Now that is a good question, and I'm not sure. I'm asking you because I really don't know. The coordinates would not change. To me, it looks more like a flip, or not a flip, a reflection. You know what I'm saying? Like if I'm going to rotate this about the origin 180 degrees, wouldn't that make this the line of reflection? So then C would be, if C is, wouldn't C be like this? Right here? Oh, maybe, I don't know. It's not like a perfect reflection. Maybe not. Ooh, you guys, I don't like this one. This one's really, really tricking me. I'm gonna just write down the coordinates real quick and see if I can see a pattern, okay? A, B, C, D. Coordinate A is -4 up 3. B is -2 up 5. C is -1 up 2. And D is -2 up 1. Okay, so I can't do the logic of this, I don't think. Because if I did the logic of this, it would just go 180 degrees. Or I mean 90 degrees. If I wanted to do it again, maybe what that means is maybe they don't switch places, like, you know, like 4 doesn't go where 3 is and 3 doesn't go where 4 is. But maybe their negative signs change? Let's try that. Let's see, if I had the new C, let's say the new C prime would be 1, -2. Ooh, let's try that, you guys. Let's just see what happens. Let me try making A prime, B prime, C prime, and D prime where they don't switch places, like A or X and Y don't switch places, but let's see if their signs change. So this would be +4, -3. I'm just trying this out, I don't know. +2, -5. This would be +2, -1. Let's go put those in there and see where that would be. So this would be over 4, down 3. That would be A. Well, so far so good, we're in the right coordinate. So it'd be over 2, down 5. Over 1, down 2. D would be 2, down 1. Hey, you know what? That looks pretty good to me. I think we literally just solved a whole new thing. Oh my gosh, okay. Wow. So if you're going clockwise, 180 degrees, you don't switch the X and the Y, you just switch the signs to their opposite. Interesting. How do you think the coordinates would change if you went counterclockwise? Oh no! Oh boy. Well, here's what I think. Counterclockwise would mean it would go from here to here, right? So then wouldn't it not change? Like, this is 90 degrees, this would be 180. This is 90 degrees, this would be 180. So, no, they wouldn't change at all. Yay! No change. 180 degrees counter clockwise is the same as 180 degrees clockwise. Yay, so there's only one rule. Oh my gosh, you guys, this is so exciting. We made up a whole new rule. Awesome. They don't switch places, just their signs change. Wow, that's so exciting. Cool. Now let's try to use that rule for number 8. Diego draws triangle FGH in the coordinate planes, where F is this, G is this, and H is this. He rotates it 90 degrees counterclockwise. You guys, we're going to be using these rules. These rules say if you rotate counterclockwise, you switch the numbers in their places and the y coordinate switches to its opposite. This is super easy. Nothing like what we just did. Okay, so that means that F prime, G prime, and H prime. Okay, so they switch places. So F would be, so the -3 is here, and the -1 is here, right? But then only the y coordinate changes. This was the y coordinate, so now it's going to be a +3. Okay, so I'm going to flip G, so it would be -5, -3, but this is the y coordinate, and so it's going to change to a positive. I'm going to flip H, so this would be -2, -5. They switch places, but this is the y coordinate originally, which means it's going to change into its opposite. Hooray! That's all we do. Alright guys, we will do these pages together in class. Come with your questions. I know this was a little bit trickier. Rotating is, that's why I told you guys, rotating's not my favorite. But you know what? After today, it kind of is. There's some fun little rules. Alright, see you guys later.